We are, come on, live. Okay, today it is today's date. Was it 1/6? Yeah, 1/6/2020. Wow. Okay, so what we want to do is this. The unit circle, the circle itself that we've been learning, is a great way to learn trigonometry. It really is, because everything we see about sine, cosine, and tangent is up there, okay? But then the real application, the very best application of this thing is all around us. Waves. Anywhere you can see a wave. If you're an engineer and you're looking at some kind of wave, you need to know some information about the wave. Now, if you're going to put that into a computer so that wave can then send something to your phone and back, it travels in waves, right? Now the waves it travels in are in sine waves. We're going to do sine and cosine and tangent waves, but the sine waves is what you hear in science all the time. They'll say, well, it travels as a sine wave. If you haven't heard that term, then you haven't been listening in your science classes, because your science teachers are going to say that about a sine wave, okay? So if you take the sine values, right, start at 0, right? And as the sine values go this way, they get bigger, all the way to a height of 1. And then they go and get smaller to 0. And then they become negative, right? They become negative. Now, all I'm doing is going around a circle. Well, watch my hand. If I start here, right? Actually, I'll start over here. Let's start here at 0. The sine goes up. Think about the wheel, turn it, comes down. It goes back up, and there's one wave. That's one full wave, right? And it's going to go as a wave. It's going to keep going and going and going and going. And there are so many things in this world that travel in waves, okay? So what we want to do is make a little dot to dot. So sine wave or a sine graph, what we're going to do is these are theta, these are my angles, but my sine values of my angles, okay? And these are my y, which are my sine or my y values for my sine, okay? So sine is the y values from my unit circle. So let's go ahead. You guys have your chart in front of you. You've got page 236. So real quickly, 0. What is the value of 0 degrees or 0 radians? It's 0, isn't it? Now pi force on this graph, as far as the scales, pi force would be there, right? So I've got a value at 0. At pi force, my value of pi force, my sine is square root of 2 over 2. And you guys have that chart in front of you. Square root of 2 over 2 is about 0.7. It's about 0.7. So I'm going to go up to about 0.7 and put a dot, okay? So square root of 2 over 2 is about it's about 0.707. We'll just say 0.7 is good enough for us, okay? Pi halves, the y value is 1. Okay, we're getting that just from the unit circle or from your chart that you guys just did in your book, right? Now, 3 pi force is right about here. 3 pi force, as far as our scales go. And the value of 3 pi force is square root of 2 over 2, which is about a 0.7. So we'll put a dot right here, about a 0.7. All we're doing is taking our values here. 0 at 0 degrees, okay? Pi force, the sine value is 0.7. Pi halves, the y value is 1. 3 pi force, value is 0.7, okay, 0.7, right, 0.7. And then if we go all the way down to pi, the y value is 0. So we're just going to do a dot to dot. 5 pi force is here as far as my scale goes. And 5 pi force, according to my unit circle, is negative square root of 2 over 2, which is a negative 0.7, which is about there. Oh, I'm in the wrong spot. Sorry, right there. Ignore that. 3 pi halves is a negative 1 value for my sine. I got 7 pi force, which is right here. 7 pi force is negative square root of 2 over 2, or negative 0.7. And then 2 pi for y is back to 0. So I took the y values. 0, 0.7, 1, 0.7, 0, negative 0.7, negative 1, negative 0.7 back to 0, okay? So we went around the circle one full time, didn't we? Okay? So that's one curve. That's one curve. Think about when you drop a pebble into the ocean or into a pond, one curve. But it keeps going, doesn't it? Yeah, Austin?
Is there a reason we didn't do 11 pi over 6?
Yeah, in fact, golly, you're ahead of me all day long. I like that. You're thinking. When I connect the dots, Austin, when I connect the dots, it's there. It's there. When I connect the dots, 11 pi thirds is right about here. So what we really need is the basic shape. Now they're there, and we could put them all on here. It would just mean more axes and more points, right? Does that make sense? We could make it super accurate. We could have more angles. We could have more points, be more accurate. But what we need is generally the general shape, okay? And so we got the general shape. So you guys see this shape? That is a sine curve. That's one sine curve. So we're going to say that one period. We call it the period. The period is one wave. The period is one wave, one full wave. The period is one full wave. And the period is the length of that. So the period is the length of one full wave. So the length is from 0 to 2 pi. So 2 pi is the period. Now the reason that is important is this. When we change the period, you change the frequency. Okay, frequency. That sounds like a radio, right? Okay, now the frequency is like this. Well, I have a really high frequency. I have a really high voice. I know, go ahead, laugh. Okay. But what happens to the wave is this. If I talk in a really low voice, it's a really long curve. That makes sense. Think about a guitar. You got a bass note on a guitar, and you hit the bass note on the guitar. You get a long. You can see the wave, right? And then when you get a really high note on a guitar, and you strike the guitar, you can see it vibrates much more quickly, right? So a smaller wave means a higher pitch. A longer wave means a longer pitch, but the longer pitch means a longer wave. So for this one, we just got one wave is 2 pi. We're going to change this. We're going to make this become a faster wave, which means a faster pitch. Yeah, Austin?
How would you write a period or a length?
You're ahead of me. Let me keep going, okay? You're ahead of me, okay? So we're going to change this number here, Austin. But we're going to get to that, okay? You're ahead of me. I'm going to flip the page. I'm going to show you. Okay, now, another thing that you notice on this is there's a thing called the amplitude. Okay, the amplitude is like the height. Now, we have to be careful because the height is like this. Pretty simple. Okay, watch. This was the C, right? And this is sea level, right? Your wave is going to pitch you up to a height of 1, and it's going to pitch you down to a height of -1. The amplitude is not 2. The amplitude is not 2, it's 1, because you're sea level. You're either going to go up to a height of 1, or you're going to come screaming down to the height of -1. Does that make sense? So the amplitude is 1. It's the height of the curve going up, or the height of the curve going down. But the amplitude of this is 1, okay? So we're going to call B our frequency. And the frequency is simply the number of curves that we see in 2 pi. It's the number of curves in 2 pi, okay? Frequency. So when they talk about frequency, they're talking about number of waves. Frequency is like how many. Does that make sense? You guys have heard that in other, like in English class about frequency or something? It's like how many, or in a science class, how many, right? So if I take a look at this curve, I have 1. Frequency of this curve is 1 because I have 1 curve in 2 pi, right? We're going to change that when we flip it over, okay? This is a frequency of 1 and an amplitude 1. This is our standard curve. This is our standard sine curve. We want this thing memorized. I'm not saying you will memorize it, but this is the standard curve, okay? Now, let's take a look at cosine. So I've shifted up to cosine. And take a look at your book and go to 237. You see your cosine values on 237? So go look at page 237. Now cosine is the x values, okay? So what makes cosine different is one thing. Exact same shape, exact same width, exact same height, because it's the unit circle, right? The difference is where it starts. Cosine is the x. It starts at 1. So on my curve, on the cosine, I'm looking for my cosine values, it starts at a height of 1. Cosine value is, Parker, you should write this down, I'm talking, okay? Cosine value is 1. So we start at 1. We've got a point here at 1. Okay? And pi force, let's put pi force in there. Pi force is here. What's the cosine value of pi force? Square root of 2 over 2, which is a value of about 0.7. So we're going to put a value of about 0.7 here. Estimate there. And then Austin, the pi thirds, they're there, but we don't want to put them all in there because it's just too many points, right? What's the cosine value of pi halves? It is 0. Good. It is 0. 3 pi force. I'll put 3 pi force in here. What's the cosine value at 3 pi force? Yeah, perfect. It's negative square root of 2 over 2, but it's approximately negative 0.7. Nice job. So about there. What's the cosine value at pi? Negative 1, right? Negative 1. Good. 5 pi force is about there. What's the cosine value of 5 pi force? Negative 0.7. Yeah, negative 0.7. Good. That's right. 3 pi halves. What's the cosine value at 3 pi halves? 0. It is 0. 7 pi force is right about there. Okay. And what's the value? Positive 0.7. But you got the right idea. I'll show you. It's this one right here. 7 pi force is here, J, and the x value is positive.
Oh, is it? Yeah.
No, you're doing great. And then 2 pi. What's the cosine value at 2 pi? 1. It's okay. It's easy. It's the x, right? It's the 1. Now, take a look at our curve. It looks identical to the one we just drew, except for it's just in different places. Okay. So I tell kids when I learn this that when you go and you want to graph the sine, you want to start. It's like a roller coaster. You start here and you go up, right? This is like a roller coaster, except for you got to walk up the stairs to get on top of the roller coaster, or like the water slides. Either way, but you start on the top, and the cosine curve goes like this. So here's one cosine curve, and then Austin, the pi thirds, they're there, but we just don't need them. Okay, so now let's ask ourselves some easy questions. First of all, what's the amplitude? Amplitude's the height, right? What's the amplitude? Has a height of 1, right? Height of 1 down to negative 1 is the height. The amplitude is the height. And the height is 1. Good job. Amplitude is 1. And the period, how wide is one curve? 2 pi. Good. 2 pi is my... And the frequency is 1 because we have one curve and 2 pi. Okay, we're going to talk more about that, okay? So, before you go any further, the big key is this. Do you see the difference between the two curves? Do you see the difference? What's the difference? You take a look at two curves, what's the difference?
It starts at 0.
Yeah, sine starts at 0 and goes up, and cosine?
Starts at 1 and goes down.
Right, exactly. That's the only difference. Now, in science, you don't ever hear the term cosine. You always hear the term sine wave. You never hear cosine wave because we could really technically make every cosine curve into a sine curve by starting back here, right? So they never talk about a cosine. We will, though, because it's a math class. We'll talk about a cosine wave, okay? So turn the page. Let's see what we got. So before I start this, let's go ahead and on the side, I'm going to draw a normal sine curve. I'm just going to put a small mini version of a normal sine curve so you see it. 1, negative 1. So I'm just going to draw a mini one of these. So we got an idea what it looks like, okay? So a mini one of these. And when I graph these curves, they really have 5 key points. 5 key points. So when I graph these, it's really important you see this, okay? It starts at 0, it ends at 0, and halfway it's at 0, okay? Watch. When I do a sine curve, right? Starts at 0, goes through pi 0 and 0. At pi half is up at 1, and 3 pi half is down at negative 1, okay? So those are the 5 important points. I need to know that because I'm going to take and try and put those 5